When an object is in either tension or compression, the net force acting on it is zero, but the object deforms by changing its original length. For example, a rod of length L and a uniform cross-sectional area A is subjected to a longitudinal pull. In other words, two equal and opposite forces are applied at its ends in order to stretch the rod. Here, the stress acting on the rod is equal to force applied divided by cross-sectional area. And strain is the measure of the deformation of an object under stress. Strain is defined as the fractional change of the object's length when the object experiences stress. Since the force applied in this case is in one direction, therefore, the stress in the present case is called linear stress, tensile stress, or extensional stress. If the direction of the force is reversed, then change in length is negative. This stress is known as compressional strain and compressional stress. If the elastic limit of a material is not exceeded, then from Hooke's law, stress is directly proportional to strain, or stress equal to Y into strain. This implies Y is equal to stress upon strain, which is equal to force into length divided by area into change in length. Here, Y is the constant of proportionality, and it is called the Young's modulus of elasticity of the rod. Unit of Young modulus is Newton per meter square. Let's solve an example to understand this concept better. Question. A 0.1 kg mass is suspended from a wire of negligible mass. The length of the wire is 1 meter and its cross-sectional area is 4.9 into 10 raised to the power minus 7 meters square. If the mass is pulled a little in the vertically downward direction and released, it performs simple harmonic motion of angular frequency 140 radian per second. If the Young's modulus of the material of the wire is n into 10 to the power 9 Newton meter per square, the value of n is... Solution. We are given area equal to 4.9 into 10 to the power minus 7 meters square. Angular frequency is 140 radian per second. Length of wire is 1 meter. Mass of the object equal to 0.1 kg. If the particle is performing SHM, then equation of motion is given by force